Carl Friedrich Gauss. Henri Poincaré. Although there was a Kantian consensus prevailing at the time, when non-Euclidean geometry was formalized, some began to wonder whether physical space was curved. Carl Friedrich Gauss, the German mathematician, was the first to consider an empirical investigation of the geometric structure of space. He thought of testing the sum of the angles of a giant stellate triangle, and there are reports that he actually tested this on a small scale by measuring the top of a mountain in Germany with the help of trigonometry. 13. Henri Poincaré, a 19th-century French mathematician and physicist, introduced an important insight that sought to demonstrate by experiment the futility of any attempt to apply geometry to space. 14. He considered the situation that scientists would encounter if they were confined to the surface of a hypothetical large sphere with specific properties, called the sphere world. In this world, the temperature varies in such a way that all objects expand and contract in the same proportion in different places in the sphere. With a suitable drop in temperature, if scientists try to use measuring rods to determine the sum of the angles of a triangle, they may be deceived into thinking they are in a flat surface rather than a sphere. 15. In fact, scientists cannot in principle determine whether they live in a flat space or a spherical space, and Poincaré says the same is true for the debate about whether real space is Euclidean. For them it was a matter of agreement which geometry was used to describe space. Einstein edit. Albert Einstein. In 1905, Albert Einstein published a special article on the theory of relativity, in which he proposed that space and time should be combined into a single form of spacetime. In this theory, for all observers the vacuum measured in the direction in which they are moving according to the observer. For 10 years, Einstein worked on the general theory of relativity, a theory that describes how spacetime gravity affects each other. Instead of viewing gravity as a field force acting in spacetime, Einstein suggested that it changes the geometric structure of spacetime itself. 18. According to the general theory, time moves more slowly in places that have less gravitational potential and that light rays are refracted in the presence of a gravitational field. Scientists have studied the behavior of binary pulsars and confirmed the predictions of Einstein's theories and the non-Euclidean geometry commonly used to describe spacetime.